Good afternoon, everyone. I'm really excited to be here. I work at the U.S. Coast Guard headquarters as a program analyst. I'm responsible for strategic planning and performance measurement. And I face the challenge that I know a lot of you face. We intuitively know that our mission, we're improving navigation, safety, and efficiency. But how do we measure it? I've struggled with this for the 2.5 years I've been at Coast Guard headquarters, and along the way, my shipmates have taught me things about marine investigations, ATON operations, and have actually delved into statistics books. And I think I found a way, and I'm pretty excited to present it to you because not only will it help me with my job, but it could potentially help all IALA member nations. And to do this, I'm going to give you an overview of the problem. We operate navigation safety systems. I'm going to talk about the methodology that I borrowed from the medical community. Then I'm going to apply it to the U.S. situation, a case study of U.S. groundings between 2003 and 2009. And then I'm going to talk about the challenges and opportunities of applying this method to our Marine administration. So I define navigation safety systems as systems of programs working together to primarily prevent navigational accidents. That's collisions, elisions, and groundings. What makes this hard is that navigation safety systems are part of a larger marine safety system. So when we have a grounding, accident investigation policy says, hey, that grounding was a result of one or more failures in the marine safety system. So if we have a grounding or we have a collision or elision, we have to resist the urge to say that it's visual aids to navigation fault. As you know, navigation safety systems are critical to safe and efficient navigation. They're tailored to address the specific risks within a waterway, and they can be very expensive. They're capital intensive and have high operating costs, but more importantly, it's hard for us to quantify their benefits, and that makes it hard for us to work with our agencies and our central governments to get the funding we need to do our mission. So what I did is I realized as I thought about this problem and I talked to my shipmates at Coast Guard headquarters, is that when you look at navigation safety systems or programs, they include REGs, they include vessel traffic services, visual aids to navigation, vessel traffic measures. Some of these are constant, so your regulations and your navigation standards for bridge equipment, these things are constant and universal. But some of them vary by location and risk. So if you have a risky waterway, you may put out more visual ATON. You may provide a higher level of radio navigation service. You may have a VTS. What it is that by the risk in the waterway, you're providing more ATON services. So I thought about this and I realized, and looking through some statistics books, that navigational accidents are a lot like a medical condition. So as maritime administrations, we are providing treatments to risks. And the more services we're providing, the more riskier it is the waterway. So using that approach, I can use a contingency table approach, or i.e. evidence-based medicine, to estimate how effective our different services are at reducing the risk of grounding in this case. And just kind of what I'm going to do here, this is just a visual representation of what I'm going to do statistically. You always have a control group, and what you want to say is what are the differences between the experimental group and the control group, and are they statistically different? I.e., is the difference due to something other than chance? So now I'm going to go ahead and apply this to the U.S. This is just to kind of give you a scale of our marine transportation system. We have 95,000 miles of coastline, 25,000 miles of navigable waterways, 12,000 of those are rivers, 200 locks, 361 ports, 1,000 harbor channels, and 3,000 passenger and cargo facilities. And to meet that mission on an operational basis, we have one navigation center that's providing navigation center and various units at different levels of the Coast Guard, providing real-time or near real-time information on the status of the marine transportation system. We have 65 buoy tenders and 65 aids to navigation teams, and they oversee 50,000 federal aids, U.S. federal aids, and monitor the condition of 50,000 aids that are maintained by private organizations within the United States. We have 12 vessel traffic services and 1 differential global positioning system. So, one metric we use to measure our performance is the aid availability rate, and this is the visual ATON. We are in accordance with IALA standards, and as you can see, there's very little variation across the top. Here is the way we measure our performance in terms of groundings is we set our target and we compare the number of groundings to the actual number of groundings to our target. So this is kind of misleading if you look at this chart. So every year we would have been reporting, so in 2003 we had 998 groundings and our target was 885. But if you look at the whole span from 2003 to 2009, the total number of groundings has been going down. Now it's my argument, and from looking at my research, that the aid availability rate, which IALA has standards for, and counting the number of groundings, are necessary but not sufficient to determine our impact. We have to, the assumption is that we provide reliable aids to navigation. So having a high availability rate means the mariner can depend on it. And groundings are an indicator of what's happening, but they don't tell us what the consequences are. We could have had 818 Exxon Valdez's, or we could have had 818 ships touching bottom in the Mississippi, which is just mud. Not all groundings are created equal. So what I realized, talking to my marine investigator friends at the Coast Guard, is that we could start to break groundings into what's called serious marine incident. U.S. Code categorizes an accident or incident into 2 categories, serious or not serious. And to be serious marine incident, you have to have 1 or more deaths, have an injury of a crew member that requires medical treatment, have a damage to the vessel or a loss of the vessel, oil spill greater than 10,000 gallons, or the discharge of a reportable quantity of hazardous substance. So now, we've acknowledged that fact that not all groundings are significant, but then they also vary by location. Our investigators, when they do their investigation, categorize groundings in 1 of 3 locations: a marked channel, outside the marked channel, and an unmarked waterway. So using that existing accident investigation and our existing code, we can now do a contingency table, or a 2x2 table, and run statistics to look at how our navigation safety services, or ATON, our treatments, vary, the rate of accidents vary within these 3 categories. And since I'm doing a 2x2 table, I can't do them all 3 at once. I have to choose a reference group. So I chose the marked channel as the reference group because that's where we're focusing our efforts. And this is what it looks like. Every ship that goes in a marked channel is exposed for the potential of grounding. Same in an unmarked water.